Hello, welcome to my video. My name is Asam Zimsondamwamba and I'm going to be explaining my works in sound sampling and synthesis to the question 2, which reads, using frequency modulation synthesis with 3 operators, create a definite pitched bell sound that can be used to accompany a piece of music harmonically. So this is the sound that I came up with. So now how did I create this sound? So I used these modules. The first module was MIDI to CV, which is basically helping me to send MIDI information, input information to trigger the operators or oscillators that I'm using. Then the other thing is that it is also helping me to send the octave voltage octave information, and also it is helping me to send get signal information to the operators. So here the other modules that I'm using are the 3 operators, which these 3 operators, which 2 of these are acting as modulators, and then the third one is acting as a carrier. So basically this is the sound that we are hearing that's giving us the definite pitch that we are hearing. It's from the carrier, and then these modulators are basically affecting the harmonics of the carrier. Yeah, the other module that I'm using is a VCF, which is basically working as a filter, filtering out certain frequencies at a set frequency range. And then the other thing I'm using is a VCA, basically for amplitude or level. Then the other thing I'm using is a mixer, which is just optional in here, though I'm using a mixer just to control the volume. And then the other thing I'm using is the scope, which is being used for visual representation of the sound that's being reproduced. And then the other thing I'm using is this envelope, ADSR envelope module. And then the other thing I'm using is audio output, so that I can hear the sound that I'm making through my monitors. So here I had to route voltage octave output signal into the voltage octave input on all the 3 operators. As you can see, this yellow line represents voltage octave information, and then I had to route the gate output information from the MIDI CV into all the operators gate input. As you can see, this red color representing the gate. I had also to route it to the external envelope that I used here. And then the other thing I routed is that I had to get the output or the first modulator into the input of the second into the frequency modulation of the second modulator, and then I had to get the output of this modulator and then route into the carrier input frequency modulator input there. And then I had to route the carrier's output into the VCF input. I had to create a cutoff frequency at 800 Hz, and then I had to route the high pass filter. With the high pass filter, I had to route it into the VCA. And then the other thing I routed was the gate envelope into the VCA input as well there. Then the other thing is the voltage controlled amplifier output. I had to route it into the so from the VCA I had to route it into the VCA mix channel 1. Then I had to get the output from the mixer into the scope left and right, and then the output signal from the scope into the audio output left and right. That's how I routed this patch. So the other thing I did is now how I created this bell sound using these 3 operators. So bell sounds are basically known to have a very fast attack. So I had to first start by setting my envelope. So I had to switch on the envelope button here. So because when these buttons are not switched on, the envelope won't be responding. So I had to turn this on all the operators. On the modulators, I had to turn it on the modulators as well on the carrier. So here to start with the envelopes on both of these operators. I had to start with the first envelope on the carrier. I had to set a very fast attack at 0 second, and then I had to set a decay at 1.5, and then I had set a very fast sustain, and then I had set my release at 2 seconds, and then the level I'd put it at 100 Hz. On this modulator to set a very fast attack as well with a decay of 0.5 seconds. Again, I had to set a very very fast sustain, and then with a release of 1 second with a volume or level set at negative 20 dB. The other thing I did is that on the other modulator, the first modulator, I had to set a very fast attack as well, and then I had to apply a decay of 1 second, a very fast sustain as well, and then with a release of 0.2 seconds with amplitude level of negative 30 dB. So for the feedback, I'd set 5% on the first modulator. I'd set 5% on both the modulators, and then I'd set 20% feedback on the carrier's modulator. Set the depth percentage at 30% on the first modulator here, and then this one was the second modulator was at 0, and then for the carrier it was at 5. So basically this affects the percentage at which it is affecting the harmonics of the carrier there. So, and then for the ratio here, I'd set the carrier's ratio at 4%. So this basically affects the pitch information as well as the octave at which the sound will be played from. So with the set ratio of 4, this is the sound we hear. And then when I set this to 6, or I set it to 8, this is how it will sound. To sound at a very high octave. So I'd set it to 4 to get this sound. Then for the first on the first modulator, I'd set it at 1. For the second modulator, I'd set it at 2, and then for the third operator, which is the carrier, I'd set it at 4. So basically, the sound that we are hearing is the carrier's sound, which is our fundamental frequency, and then these two other operators, which are modulators, are affecting the harmonics of this carrier. The other thing I did is to route the output of this carrier into the VCF. So on the VCF, mostly bell sounds tend to have that bright sound. They don't have much of the lower frequencies. So I'd set a cutoff frequency at 800 Hz just to roll off those raw frequencies, and it's the sound that I got. And then I'd even set a high pass filter. So when I set it to a low pass filter, can't even hear the sound. So I'd set it to a high pass filter with a cutoff frequency of 800 Hz. So after sending the high pass filter into the VCA, I'd also to use an external ADSR envelope just to create the final sound of this bell. So I had to route the envelope out into the VCA just to create a final bell sound. So I had to again adjust the shape with a very fast attack on the envelope, and then with a decay of about 452.9 milliseconds with a 0% sustain with a release of 700 milliseconds. Yeah. So, and then the other thing I did was after routing the output of the envelope into the VCA, and I got the output of the VCA and routed into the mixer. So that's how I came up with this bell sound.